separating some of the components of apple cider into its components here. We have some things that are in this that are sugars, some of these things that are solids, materials, and then we have some things that are flavorful or have great aroma. And when we're cooking, we are heating something up a lot of times, and you are able to evaporate away some water, but when you do that, you also are sending some wonderful flavors and aromas into the air, which is great for use, as you're cooking, but a lot of that stuff ends up leaving your food. And in addition, when you're using heat, you very often are breaking down molecules which are ruining their nutritional value maybe, or changing them in some ways that it's kind of harsh. So this, although it looks very kind of threatening and very technologically advanced and everything, is actually a really gentle way of coaxing a chemical process to happen. And that's the basis of green chemistry. So it's more like just nudging the chemicals in something to do what we want them to do. And this is just a great example of this. So believe it or not, this is an incredibly healthy way to basically essentially do a cooking process that doesn't destroy or break down components of the food that you're working with here in ways that you might not want. So it's just a really neat example of applying chemical technique to produce a really awesome result. And again, it looks kind of threatening and everything, but basically this is a much more safe way to perhaps adapt food products in ways that we want them to. So with that, I'm going to give you a close-up look at some of the components of this and talk about why this is pretty neat here. So here, there's just basically a couple different components of this. So in this rotating flask that I have here is the apple cider, and it's sitting in a water bath. And so instead of like heating this super high, we're only heating this to about 45 degrees here. That's Celsius. The water temperature here is not that hot. I mean, this is like a jacuzzi bath or something. This would be very comfortable sitting in there, relaxed. And you can imagine the chemicals in here, they're just kicking back and enjoying this little warm bath here. So as opposed to heating this to a really high temperature, it's a pretty mild, low temperature. You can see it's spinning, of course, and what that's going to do, along with the heat, is it's going to promote some of the components of this apple cider to evaporate. And as it spins, it's going to increase the surface area and make it evaporate. Some of these components evaporate much more easily. So in terms of green chemistry, again, we're not like superheating these. We're not adding harsh or toxic chemicals to speed up this result. We're just gently heating this and coaxing these molecules to do something that we want them to do without really altering them. So as the components start to evaporate, they rise up this tube, and then they're going to go over here to the condenser. So you can see on this, there's little droplets of clear liquid. So those are the volatile components of the cider that are hitting this water that's just coming from over here. So we're running the tube of water up here. And I would like to be able to get this colder. When I get a chiller for this, I can get this down a little bit more. So obviously this is just at kind of a little colder than room temperature. And I kind of would like to get this down to like about -10, which is going to be tough the way I have it set up right now. But it's still working pretty good. All right, so then as this stuff condenses, you can see it dripping down here. And we're getting this beautiful clear liquid here, which is, I haven't tried it yet, but it should be really full of all of the flavors and aromas of this apple, all condensed in this crystal clear liquid that we get in here. So how are we coaxing these to evaporate? Well, there's two ways you can get these molecules to evaporate. Well, actually three. You can increase the surface area, as I mentioned, but we can also heat it. But here we don't want to heat it too highly. So instead of heating it, really what we're going to do is create a vacuum. And that's what this guy is right here. So this is a vacuum, which is connected up here to the, actually it's connected in the back there, but it's going to reduce the pressure inside of this thing. And that'll just make the atoms that we want to come off of this just kind of float into the air. So I'm going to show you how that works here. Right now it's not bubbling, it's not boiling as we would say, but I'm going to turn on the vacuum over here and try to see if we can get the pressure low enough that we start to get this to evaporate. So I'm going to make this boil not by heating but by lowering the pressure here. And I've got to stay on top of this because we don't want that to bubble too much because it goes up and into this apparatus here, which is a pain in the neck to try to clean. But you can see it bubbling, and now you can see over here drips coming off of our collection tube, the condenser here. So those are all just things that you would be smelling or maybe tasting that just evaporate naturally off of an apple. So if you imagine picking an apple maybe, and just the smell of it when you first bite into it, these are the things that we're capturing here, the things that so quickly and easily evaporate. And they're wonderful, very nutritious and flavorful different components. I'm gonna hit this vacuum one more time to see if we can get that boil. Okay. And we got the pressure down here, I don't know, somewhere around like 0.1 pascals. There we go. And we're getting a pretty good rate. So I'm really pretty happy with this whole device so far. As I said, it's the first time I've used it, and I don't actually have a cooler. You can see that the condensate's reaching a little bit too high. They say really about 3/4 is where you want it, but I think I'm pretty good. And the pressure gauge is pretty steady, which means I don't have leaks. And so far so good with this. We're going to give it another maybe hour to just gently kind of do its thing, and then I'll come back and let you know how it all worked out. All right, so here's the moment here to try these things out here. I've run this for a couple of hours now, which I think next time I do this it'll be less, but you can kind of see where we're at here. That's the remaining liquid from the cider, and here you can see we've collected quite a bit of liquid there from the condensate. And so if I turn this back on, I've already turned this all off, but just to see, you can see that we've gotten quite a bit more concentrated here with the residue from the distillation, and then over here we have the stuff that we're going to be trying here. Actually, we'll try both. So the reason that I think that I probably ran it a little too long is that I'm going to guess that perhaps there's just a lot of water in this, so we'll see. I'm gonna take some off here. And you can see it's very clear, crystal clear, I think. I'm trying to make sure we can see this, but there's no seeming like little, it's pretty watery. I'll get a little bit of those clinging to the side of the glass there. So here we go. First of all, the bouquet is great. You can really get that smell of the apple here. Yeah, it's really, really good. It's like water, really purified water that has this wonderful flavor of apple in it. Again, I think I probably ran it a little too long because it's I think maybe a little too diluted with water. I'm going to try this again and just do it for a short while, because the first things that come off of that should be some of those more volatile, flavorful, and very you know, pungent, aromatic types of things that would come off first. And then I think I've just mainly diluted it a lot, but it definitely is something happy about that. It's it's very, very nice. It's very subtle, I think, but you can distinctly get the flavor and the aroma, I think, of the apple. All right, so now back here we have the concentrate, and so I'm curious what this tastes like. Often in chemistry, this is what we'd be wanting here, because we'd be looking to purify or take out some solvents. But I think from a culinary standpoint, this could be like really good too, I'm hoping, because it may have concentrated a lot of the other flavors here. It distinctly doesn't have any odor, which I guess you would expect. It basically smells like nothing at all, so I don't know what that means exactly. I guess it makes sense because we've taken away all those aromatics. Cheers. Again, no smell at all. Wow, it's got a lot of flavor though. I should say there's a lot of sweetness to this. It's like candy, but not a lot of apple in it. It's sort of hard to describe, except that it's very, very sweet, which makes sense because a lot of the sugars should remain in this. And then it has sort of an earthy sort of ness to it that is actually really, really pleasant. I like it to be. I'm thinking that I might continue to evaporate this a little bit more and see if I can thicken that. You can see it's already a little bit thick, but I think like a syrup or something like that, it'd be really, really tasty. So, so I think I'm actually going to put that back on there. I'm going to extract what I already have there of the apple flavored water, I guess you could call it, and then maybe just play around with seeing about maybe thickening that up a little bit and concentrating it. So I'm just thinking aloud here that it might be worth it to do a quick distillation to get the aromatics off first, and then take those away, and then try it again to see what happens if we continue to play around with concentrating that. But I'm pretty happy. That seemed to work out really well, and I'm going to have fun with thinking of some other things that we could do with this. All right, we're back here again after about an hour of continued distillation here. I really cranked down the vacuum and worked this for quite a while. You can see that we're now down to kind of like a gooey caramel-like material here. It's pretty cool looking. So I'm going to stop this right now. I've already pressurized this thing, so we should be able to check this out. So again, we'll try this is the condensate here. Oops, I'm missing it. Not having high hopes for this. I'm thinking it's mostly going to be water, but let's see. Yeah, that pretty much is just like distilled water. Pretty much doesn't have really any flavor whatsoever on that. But we didn't really expect that. So let's take this off carefully and see what we got here. I'm anticipating something really, really, really sweet here because mainly it should be the sugars. But look at that, that's really kind of awesome, really. I don't know how I'm going to get it all out of here. It's probably pretty sticky. Let's see. All right, so there it is. It's almost like taffy or something. Wow. That's freaking great. It's really, really good. Wow. Feels really, really nice on the tongue. It is definitely sweet, but in a way that I don't know. It just doesn't hit you like a candy would, where like your teeth kind of hurt or something. This is just gentle and kind of soothing in a way. Kind of strange, like maybe a cough syrup or something. Actually, this would be wonderful maybe for that. It just soft on the palate. Yeah, the flavor is really, really nice on it, and very unique. I mean, I can't again say that this is apple. I don't know if I get that right off the bat, and it doesn't have much of a smell at all. Just kind of an earthiness to it. So all in all, that was a lot of fun. I enjoyed that a lot, and we're gonna play around with this quite a bit more and see what we can do.